Welcome back to the channel. So today in this video we are going to attempt question number 7 and probably question number 8 of SETS class 11th exercise 1.4 of CBSE mathematics. So question number 7 is, if set A is x such that x is a natural number, set B is x such that x is an even natural number, set C is x such that x is an odd natural number, and set D is x such that x is a prime number. Find A intersection B. So in part first, we'll have to find A intersection B. We have gone through what intersection of sets is. Here we are having a set containing all the elements which are common to the given two sets. We have gone through this very concept in the previous videos. Take for example, we have set A containing elements as 1, 2 and 3. We have set B having elements as 2, 3 and 4. So what will be A intersection B in this case? So the common elements are 2 and 3. So therefore A intersection B will be a set having elements as 2 and 3. Now let's solve part number first. Here we'll have to find A intersection B, as all the sets in this case are given in set builder form, which means our solution should also be in set builder form wherever possible. So set A is having elements as all natural numbers. So we know what natural numbers are: 1, 2, 3, 4, 5, 6 and so on. And set B is a set containing all even natural numbers, and even natural numbers are 2, 4, 6 and so on. So what are the common elements? 2, 4, 6, which means all the elements of set B are common to set A. So here the intersection will be x such that x is an even natural number, or you can say set B, as all elements of set B are also the elements of set A. Part number second. What is A intersection C? A intersection C. Here set A, as we know, is having elements as 1, 2, 3, 4, 5, 6 and so on, as it's a set of natural numbers. And set C is having elements as odd natural numbers, which are 1, 3, 5 and so on. So what are the common elements? 1, 3, 5, which means all elements of set C are contained in set A. So what will be A intersection C? It will be x such that x is an odd natural number. Part number next. Third part. What is A intersection D? Here set A is having elements as we know 1, 2, 3, 4, 5, 6 and so on. And set D is a set of prime numbers. So the elements will be 2, 3, 5 and so on. And we know what prime numbers are. These are those numbers which have only two factors, that is 1 and the number itself. So what are the common elements? 2, 3, 5. So here again one can observe that all elements of D are contained in set A. So what will be A intersection D? It will be x such that x is a prime number. Part number 4. What is B intersection C? So set B, as we know, is a set of even natural numbers 2, 4, 6, 8 and so on. And set C is a set containing all odd numbers, that is 1, 3, 5, 7, and so on. Since the given natural number cannot be even as well as odd, so B intersection C will be having no common elements, which means it will be an empty set. Part number next. What is B intersection D? B intersection D. So set B is having elements, as we know, all even natural numbers, that is 2, 4, 6, 8, and so on. And set D contains all prime numbers, that is 2, 3, 5, 7, and so on. Here one can observe that we have only one common element, that is 2. So B intersection D will be having only one element, that is 2. So this set cannot be represented in set builder form, as set builder form is usually used in case of sets which are infinite. Part number last. What is C intersection D? Set C is having elements as 1, 3, 5, 7, and so on. While as set D contains prime numbers, which are 2, 3, 5, 7, and so on. So what is the intersection? We have 3, we have 5, we have 7. So here C intersection D will be x such that x is an odd prime number. Since all prime numbers are odd in nature and 2 is excluded, so we have mentioned odd prime number. Towards the next question. Question number 8 is, which of the following pairs of sets are disjoint? So what are disjoint sets? Two sets are said to be disjoint if they have no element in common. So if two sets have no element in common, then those two sets will be disjoint. So if we have two sets, sets A and B, such that A intersection B is an empty set, meaning that there is no common element in these two sets, then the sets are disjoint. So this is the condition for sets to be disjoint, that their intersection should be an empty set. Now let's solve part number first. We have a set containing elements 1, 2, 3, 4. And we have another set where x such that x is a natural number and x is greater than or equal to 4 but less than or equal to 6. So this set will be having elements as 4, 5, and 6. So one can observe that 4 is the common element, and we already know for sets to be disjoint, A intersection B should be an empty set. Here in this case, A intersection B is not an empty set. So these two sets are not disjoint. So here A intersection B is not an empty set. Therefore, the two sets are not disjoint. Part number second. We have a set containing elements A, E, I, O, U and another set containing elements C, D, E, and F. So our first set having elements as A, E, I, O, U and second set containing elements C, D, E, and F. Here once again one can observe that E is the common element. So A intersection B is not again an empty set. Therefore, the given two sets are not disjoint. Part number third. First set is x such that x is an even integer and the second set is x such that x is an odd integer. As stated earlier, no number can be even as well as odd, which means that A intersection B in this case is an empty set. Therefore, the two sets in this case are disjoint as their intersection is an empty set. Hope this makes sense. Do subscribe the channel for more such content and thanks for watching.